Hi everybody, in this video I'm going through what you need to be able to do to blitz the first exam for Year 8 Maths. We're going to start by thinking about index notation. If I've got this expression here, we read this one here as 8 to the power of 3. We could also read it as 8 cubed. Cubed is when I have a little 3 there. This one here would be read as 8 to the power of 2 or 8 squared. Powers of 2 and 3 have special names, but everything else I just use the number. So this one here would be read as 8 to the power of 15. Let's look at 8 cubed or 8 to the power of 3. That is equal to 8 times 8 times 8. We are multiplying 8 by itself 3 times. This big number here is called the base. This number up the top here is called the index. This one here we would read as b to the power of 5. It is equal to b times b times b times b times b. This one here is 3 to the power of 4. It is equal to 3 times 3 times 3 times 3. This one here is house to the power of 2, or house squared. That is equal to house times house. What happens if I've got 5 to the power of 3 times 5 to the power of 4? What does that equal? Well, I know that 5 to the power of 3 equals 5 times 5 times 5. And 5 to the power of 4 equals 5 times 5 times 5 times 5. 5 to the power of 3 times 5 to the power of 4 is equal to 5 to the power of 1, 2, 3, 4, 5, 6, 7. 5 to the power of 7, because now I'm multiplying 5 by itself 7 times. Now, did I need to write it out like that to get that answer? No, I didn't. 5 to the power of 3 times 5 to the power of 4 is equal to 5 to the power of 3 plus 4. See these 3 here and these 4 here, which is equal to 5 to the power of 7. What we just did then was index law number 1. Have a look at it. The bases are the same. I'm multiplying the terms, so I add the indices. If we've got 5 to the power of 3 times 5 to the power of 4, that is equal to 5 to the power of 3 plus 4, which is 7. The bases are the same. They both have a 5 here. I'm multiplying the terms, so I add the indices. Notice that word I used there, indices. That is just the plural of index. A to the power of 5 times a to the power of 6. Does this index law apply? Well, are the bases the same? Yes, they are. Am I multiplying the terms? Yes, I am. So what do I just do? I add the indices. So we have a, same base, and up here we have 5 plus 6, which is a to the power of 11. How about this one? Does the index law apply here? Well, are the bases the same? Yes. Am I multiplying the terms? Yes, I am. So what do? I add the indices. It's going to be 3 to the power of 7 plus 1, which is 8. How about this time? Does the index law apply? Well, are the bases the same? Yes, we've got a sun here and a sun here. Am I multiplying the terms? Yes, I am. So what will our answer be? Sun to the power of 4 plus 6, which is 10. I've got 3 expressions here. Does the index law apply? Well, let's look at the first one. Are the bases the same? Yes, they are. Am I multiplying the terms? No, I'm not. I'm adding. So, no, the index law does not apply there. Let's look at the second one. Are the bases the same? Yes, they are. Am I multiplying the terms? Yes, I am. So what can I do? I can add the indices. A to the power of 5 plus 2 is 7. What about this one? Does the index law apply? Are the bases the same? This one's an A. That one's a B. They are not the same. So no, the index law does not apply. Here are 4 expressions. The index law applies to only 2 of them. Press pause and try and work out which ones. Okay, let's look at the first one. Are the bases the same? Yes, they are. Am I multiplying the terms? Yes, I am. So what can I do here? I can just add the indices. That one worked. What about the second one? Are the bases the same? Yes, they are. Am I multiplying the terms? Yes, I am. So I can use the index law. That gives me 2 to the power of 5 plus 4 is 9. That one works. What about the next one? Are the bases the same? No, they are not. The bases are not the same, so I can't use that index law. Next one, are the bases the same? Yes, they are. Am I multiplying the terms? No, I'm not. So I cannot use the index law for that one. Have a go at these. I can tell you that there's one where the index law will not apply. Press pause. Okay, how did you go there? The first one here, are the bases the same? Yes, they are. Am I multiplying the terms? Yes, so I can just add the indices. 3 plus 10 is 13. Next one, are the bases the same? Yes, they are. Am I multiplying the terms? Yes. So what do? I add the indices. We're going to have a 6 there. 6 to the power of 2 plus 4 is 6. Next one, are the bases the same? Yes. Am I multiplying the terms? Yes. So what do? Add the indices. Next one here, are the bases the same? Yes, they are. Am I multiplying the terms? No, I'm adding. So no, for that one, the index law does not apply. What about this next one? Are the bases the same? Yes. Am I multiplying the terms? Yes. So what do? I add the indices. 10 plus 40 is 50. Time to look at the second index law. Once again, the bases have to be the same, but this time I am dividing the terms, so I subtract the indices. How does this one work? If I have got, let's say 6 to the power of 10 divided by 6 to the power of 8, well, bases are the same. I'm dividing the terms. It's going to give me 6 to the power of 10 minus 8, which is equal to 6 to the power of 2. The bases are the same. I'm dividing the terms, so I subtract those indices. Can you try this one? Well, how do we do this? The bases are the same. I'm dividing the terms, so what do I have to do? Subtract the indices. 5 minus 2 is going to be 3. What about this one here? A to the power of 10 divided by A to the power of 6. Are the bases the same? Yes. What am I doing? I'm dividing the terms. So what do? A to the power of 10 minus 6, which is 4. Here are 5 for you to try. Now you're going to need to be careful here because some of them are divide problems and some of them are multiplication problems. Press pause and write down your answers. Okay, the first one, the bases are the same. I'm dividing the terms, so I subtract the indices. That's going to give us 8 to the power of 7 minus 5, which is 2. Next one, the bases are the same. I'm multiplying the terms, so what do? I add the indices. 5 plus 2 is 7. Next one, the bases are the same. I'm dividing the terms, so what am I going to do? I am going to subtract the indices. 5 minus 2 is 3. Next one, the bases are the same. I'm multiplying the terms, so I add the indices. 3 to the power of 11. Next one, the bases are the same. I'm dividing the terms, so I subtract. 7 minus 4 is 3. I've got 3 to the power of 3. Now I want to tell you something that I've seen go wrong in my class. We've got, let's take this one here. I've got 10 to the power of 5 times 10 to the power of 2. And I've had students say, oh, well, I know that 10 times 10 is 100, so I'll write that there, and 5 plus 2 is 7. Is that right? No, it is not right. The bases are the same. I'm multiplying the terms, so when I'm writing my answer, my base stays the same. It is still 10, and then I just add the indices. 5 plus 2 is 7. Make sure you don't actually multiply the bases. You don't do that. You just leave the base as it is and add or subtract the indices depending on whether you are multiplying or dividing. Okay, here are another 5. Now, I want you to try to answer these, but I can tell you that for 3 of them, it's not possible because the index laws don't apply. So see if you can not be confused by that. Press pause. Okay, let's look carefully and see which ones the index laws apply to. Bases are the same. I'm multiplying the terms. This one's good. So what do? I add the indices. You just leave that base as it is. 4 plus 3 is 7. What about this next one? The bases are the same, but oh no, what am I doing? I'm subtracting. So I'm going to write that. That's a no. We can't do that one. Next one. The bases are the same. Oh, I'm adding here. Can I do that? No, the index law does not apply to plus or minus. Next one here. The bases are the same. I'm dividing the terms. That's good, isn't it? So what do? I subtract the indices. 8 minus 5 is 3. Next one here. Are the bases the same? No, they are not. So I cannot answer that one there either. Okay, time to look at index law number 3 now. Here it is. Raising a power to a power, I multiply the indices. Let's think about what this one is. If I've got 5 to the power of 2, all to the power of 3, what that means is 5 to the power of 2 times 5 to the power of 2 times 5 to the power of 2. And 5 to the power of 2 is 5 times 5. So I've got 5 times 5 times 5 times 5 times 5 times 5. What does that equal? It is equal to 5 to the power of 1, 2, 3, 4, 5, 6. 5 to the power of 6. But did I need to write it out like that? No, I didn't. Raising a power to a power, we multiply the indices. 5 to the power of 2 times 3, which is 6. How about this one? I've got a to the power of 5, all to the power of 10. Well, that's going to equal a to the power of 5 times 10, which is 50. What about this one? 3 to the power of 5, all to the power of 7. That's going to equal 3 to the power of 5 times 7, which is 35. Here are 3 questions. Can you answer each of these? Okay, let's look at what we've got. The first one, we've got the bases the same, and we are multiplying the terms. So what do? Bases are the same. I'm multiplying the terms, so I add the indices. What about this one? Bases are the same. I'm dividing the terms, so what do I have to do? I subtract. 10 minus 5 is 5. Next one here, what am I doing? I'm raising a power to a power, so I multiply the indices. Here are 4 for you to do. Press pause. Hopefully you went well with those. Let's look at the first one. Well, the bases are the same. I'm dividing the terms, so I subtract the indices. That's going to give me 3 to the power of 8 minus 6. 8 minus 6 is 2. The next one, what am I doing? I am raising a power to a power. I multiply the indices. That will give me 3 to the power of 10 times 4, 40. Next one here. The bases are the same. I'm multiplying the terms, so I add the indices. 10 plus 4 is 14. Next one here. What am I doing? I'm raising a power to a power, so I multiply the indices. 3 to the power of 8. Time for the 4th index law. Here it is. Anything to the power of 0 is equal to 1. So if I have 5 to the power of 0, that is equal to 1. If I have a to the power of 0, that is equal to 1. If I have got house to the power of 0, equals 1. If I have got stickman to the power of 0, that equals 1. Anything at all to the power of 0 is equal to 1. Here are 5 for you to have a go at. Press pause. Okay, let's see how you went. First one, 3 to the power of 0. Anything to the power of 0 is equal to 1. Notice it doesn't equal 3 to the power of 1. No, it just equals 1. Next one, 3 to the power of 2 times 3 to the power of 5. Bases are the same. I'm multiplying the terms, so I add the indices. Next one. Bases are the same, I'm dividing the terms, so I subtract the indices. Next one. Raising a power to a power, I multiply the indices. So that's going to give me 3 to the power of 10 times 0. What's 10 times 0? 10 times 0 is 0. Oh, what's 3 to the power of 0? Anything to the power of 0 is equal to 1. Next one. Raising a power to a power, I multiply the indices. 10 times 10 is 100. Okay, go. See how fast you can write down the 4 answers for these. You finished already? The first one, raising a power to a power, I multiply the indices. Second one, anything to the power of 0 is 1. The third one, bases are the same, I'm multiplying the terms, so I add the indices. Final one, bases are the same, I'm dividing the terms, so I subtract the indices. Here's a trickier one. How would we do this? Well, we've got a to the power of 5 times a to the power of 2. Well, the bases are the same here, and I'm multiplying the terms. So what do I do for that bit? I add the indices. Now then I've still got these brackets around it, and that like that. What do I do next? Well, raising a power to a power, I multiply the indices. Okay, let's think again about how I did that. First thing I did was I started by working out this bit inside the brackets, and then I applied that power of 10 after that. Let's have a go at this one. How would we do this? What would be the first thing we do? That's right, we're going to do this inside bit first. A to the power of 11 divided by a to the power of 4. Bases are the same, I'm dividing the terms, so I subtract. 11 minus 4 is 7. Then I'm just going to put those brackets back. And then what's next? Raising a power to a power, I multiply the indices. Stop for a minute here and explain some different ways of notating things. Here I've got a to the power of 7 divided by a to the power of 4. I could also write this as a fraction. A to the power of 7 over a to the power of 4. Those two mean exactly the same thing. This one here, bases are the same, dividing the terms. A to the power of 3. This one here, exactly the same. A to the power of 3. That line there simply means divide. It is another way of writing divide. Have a look at this one here. How would we do this? Well, the first thing I'm going to do here is this top bit. It's going to say, well, bases are the same, I'm multiplying the terms, so I add 5 plus 10 is 15. Then I'm just going to put that denominator just as it is. What have we got here next? Oh, we've got a division. The bases are the same, I'm dividing the terms, so I subtract. 15 take away 3 is 12. How about this? What would you do here? Well, the first thing we're going to do is fix up the top. We've got a to the power of 5 times a to the power of 4. Bases are the same, multiplying the terms, so I add the indices. The next thing we're going to do is the bottom here. Again, the bases are the same, I'm multiplying, so I'm going to add the indices. 3 plus 2 is 5. Oh, what have I got now? Now I've got a division. Bases are the same, I'm dividing, so I subtract. 9 take away 5 is 4. How about this one? How would we do this? Press pause and give it a go. Well, I'm going to start with the top. A to the power of 12 divided by a to the power of 2. 12 minus 2 is going to be a to the power of 10. I'll just do my fraction there again. I'm next going to do this bit down here. A to the power of 3 times a to the power of 4. Bases are the same, I'm multiplying, so I add. 3 plus 4 is 7. Next one, what have I got? I've just got a division here. A to the power of 10 divided by a to the power of 7. 10 minus 7, a to the power of 3. Oh, how would we do this one? This one is going to be worth a lot of marks. There's probably 4 or 5 marks on an exam for a question like this. How are we going to do it? I'm going to start with this part here. A to the power of 5 times a to the power of 2, that will give me a to the power of 7. Then after that, I'm just going to write power of 4, And then over, I could clean up this bottom bit, couldn't I? 8 to the power of 30 divided by 8 to the power of 10. Well, dividing, so I'm going to subtract 30 divided by 10 is 20. Next thing I'm going to do is this here. Raising a power to a power. What do? I multiply the indices. 7 fours are 28. I've got 8 to the power of 28 still over 8 to the power of 20. Well, that's just a division problem now. 8 to the power of 28 divided by 8 to the power of 20 is 8 to the power of 8. And that's my answer. Now, if that was on an exam, let me show you all the marks you'd get. You get 1 mark for getting the 8 to the power of 7 correct there. Another mark for the 8 to the power of 20. Another mark for applying that index law there. And another mark for that there, your final answer. Have a go at this one here. I can tell you that this one here is probably worth 5 marks. When I'm doing these ones, I always start by writing them down, then work them out piece by piece. Well, what do we start with here? This bit here. Bases are the same. I'm dividing the terms, so I subtract. Then I'm just going to do that as usual. Let's work out the bottom now. Bases are the same. I'm multiplying, so I'm going to add, so that's going to be a to the power of 5 there, and then go like that. Then next I'm going to do the power of the power to the power rule. Raising a power to a power, I multiply. Now remember, you can use your calculator for this if your number facts aren't very secure. This one here, 5 times 5 is 25. And then what have we got? We've got a division. A to the power of 32 divided by a to the power of 25 is a to the power of 7, and I'm done. Now having a look at this one here, can you notice how these big brackets are around all of it? That means that raising it all to the power of 10 is going to be the very last thing I do. So firstly, I'm going to do this bit on the top. That will give me, bases are the same, I'm dividing the terms, so I subtract. 30 minus 20 is 10. Then I'm going to do this bit here on the bottom. Multiplying, so I add. There we are, and I'll just write that there. Now I'm going to do this division bit here. So a to the power of 10 divided by a to the power of 5. 10 minus 5 is 5. Then I'll put that there. And then last of all, I'm going to apply that. 5 times 10 is 50, like that. Okay, that's all of the index law work that you need to be able to do, but we need to do some other things involving algebraic terms. Have a look at this. If I've got 3a plus 2a, how many a's do I have? Well, I've got 3a here, I've got 2a here. 3 dogs plus 2 dogs equals 5 dogs. 3a plus 2a is equal to 5a. What about this one? 3a plus a. Well, I've got 3 a's here. How many do I have here? I've actually got 1. So 3a plus a gives me what? 4a. What about this one? If I've got 7a, take away 2a, what does that give me? 7 ants, take away 2 ants will give me 5 ants. 7a, take away 2a will give me 5a. Now I'm going to show you something here that kids find quite tricky and make a lot of mistakes with. If I've got a times a, that is equal to a to the power of 1, because if there's no power, the power is actually 1. A to the power of 1 times a to the power of 1. That is equal to a to the power of 2. Bases are the same. I'm multiplying the terms, so I add the indices. A to the power of 1 times a to the power of 1 is a to the power of 2. Now have a look at this one here. A plus a. Here I've got 1a and I'm adding another 1a. What have I got? Altogether, I've got 2 a's. Let's look at that again. Let's say I've got m plus m and I've got m times m. Well, here I'm adding. I've got one of them and I've got another one of them. What do I have altogether? I've got 2 of them. Now this one here, m times m, I'm multiplying. Remember that this is m to the power of 1 and that is m to the power of 1. So what do I have altogether? Bases are the same. I'm multiplying the terms. I add the indices. Okay, what about this one? 3a plus 2a. What do I have there? 3 of them plus 2 of them. I've got 5 of them, 5a. Have a look at this one. A to the power of 3 plus a to the power of 2. Well, can I do that? No, I can't do that. See, the bases are the same, but I'm adding the terms. The index law doesn't apply, and I'm not adding two things that are exactly the same. A to the power of 3 and a to the power of 2, they are not like terms. They are different. I can't add them up, okay? I can multiply them. A to the power of 3 times a to the power of 2, that will give me a to the power of 5. I can multiply them, but I cannot add them. But 3a plus 2a, see how there's no powers there? That just gives me 5a. Have a look at these. Can you answer all of these questions? Well, the first one, a plus a. I've got one a and I've got another a. I'm adding them together. What have I got? I've got 2a. What about this next one? I've got 3a over here. I've got another 2a over there. Adding them together, what does that give me? 5a. Oh, this next one, what is it? Bases are the same. I'm multiplying the terms. So what do? I add the indices. 10 plus 3 is 13. Next one here. The bases are the same. I'm dividing the terms. So I subtract the indices. Next one, raising a power to a power. I multiply the indices. Have a look at this one. 3a times 2. This means I've got two lots of 3a. I've got 3a over here, a plus a plus a over there, and a plus a plus a over here. What have I got all together? I've got 6a. 3 times 2 is 6. 6a. What about if I've got 3a times 10? What have I got? I've got 30a. Now here's something that looks similar but isn't. I've got 3a times 10a. What's the difference there? Notice here there's no a here. 3a times 10a, here's what I do. I multiply the numbers. 3 times 10, that's 30. And I multiply the a's. I've got a times a. What does that give me? A squared. 30a squared. Okay, here are 5 different problems that all look kind of similar, but they're not. How do we go with them? Well, the first one, 3a times 10. That is 30a. Notice a is here, but it isn't here. This next one, I've got 3a times 10a. How do I do that? I multiply the numbers and I multiply the letters. A times a, well, that's a to the power of 1 times a to the power of 1. Bases are the same. I'm multiplying the terms, so I add the indices. Next one, 3a plus 10a. 3 of them plus 10 of them will give me 13 of them, 13a. Next one, oh, bases are the same. I'm multiplying the terms, so what do? I add the indices. That's a to the power of 13. Next one here, raising a power to a power, I multiply the indices. A to the power of 30. How did you go? Did you get all of those ones right? Here are 5 more. The last one's a bit tricky, but I wonder if you can work out how you would do that. Press pause. Okay, the first one here, we've got 10a times 2a. I multiply the numbers and I multiply the letters. Remember, a to the power of 1 times a to the power of 1, a to the power of 2. 20a squared. Next one, 10a times 2. Notice there's no a's here. It's just times 2. So 10 times 2 is 20, and then the a just sits there. Next one, bases are the same. I'm multiplying the terms, so I add the indices. Next one, raising a power to a power, I multiply the indices. Now, this is the last one that we haven't done these ones before. We've got 10a to the power of 5 times 2 lots of a to the power of 3. How do I do this? I multiply the numbers. 10 times 2 is 20. Then I multiply the letters. A to the power of 5 times a to the power of 3. That is a to the power of 5 plus 3 is 8. Okay, next question. How do we simplify this expression? Can you see how we've got 4 different terms and we're adding them all up? Here's what I'm going to do. I'm going to find all of my A terms. I've got 3A here and I'm adding 2A. Notice I put in that plus sign there in the box, and I've got 5B here, positive 5B here, plus 7B. Now I'm going to deal with the A's first. I've got 3 of them plus 2 of them. That gives me 5A. And with the B's, I've got 5B plus 7B will give me 12B. So our answer is 5A plus 12B. Look at this next one. 7A plus 3B minus 2A plus 5B. What am I going to do? Firstly, I'm going to identify my like terms. I've got 7A's. What else here? I've got, negative 2A's. Notice I'm boxing that minus with the 2A. This minus is owned by the 2A. Then I've got positive 3B here. I've got positive 5B here. Then I'm going to deal with my A's. 7 of them minus 2 of them will give me 5. 7 minus 2 is 5A. Then with B's, plus 3B plus 5B, that's going to be, leaves me with positive 8B. So I write it like that. Have a go at this one. Minus 2A plus 3B plus 4A minus 5B plus A. Okay, first thing I'm going to do is identify my like terms. I'm going to use purple for all the A's. Notice here the sign that comes before it gets boxed with it. Okay, and pink clouds for the B terms. Okay, let's look at the A's first. Negative 2 of them, plus 4 of them, plus, how many's here? 1. So I've got negative 2 plus 4 plus 1. Negative 2 plus 4 gives me 2, plus 1 is 3. So I'm finishing with 3A. Now what about my B's? I've got 3 of them here, take away 5. 3 take away 5. Use my calculator if I need to, but that gives me negative 2B. So I just write it like that. How about this next one? 2A minus 4B plus 3A plus 6B minus 5A. First step, find my like terms. Purples for the A's. And pink for the B's. How many A's do I have? 2 of them. Plus 3. 2 plus 3 is 5. 5 take away 5. 5 take away 5 is 0. I've got 0 A's. How many B's? I've got minus 4 plus 6. That gives me 2 and gives me positive 2B. Now, how do I write this? I've got no A's, so I don't even need to write that. My answer is just 2B. I could put a positive out the front, but I don't need to. Just a couple more things to learn now. We're going to expand brackets. We did some of this in grade 7. This means 5 lots of 2A plus 3. There is an invisible little multiplication sign in here. That is equal to 5 lots of 2A. What's 5 lots of 2A? 5 lots of 2A is going to give me 10A. And then I've got 5 lots of positive 3. 5 lots of positive 3. 5 3s are 15. Positive 15. So 5A plus 15. How about this one? 10 lots of 2A minus 6. Remember, that's a hidden little multiplication sign in there. That gives me 10 lots of 2A, which is 20A, plus 10 lots of negative 6. 10 times minus 6 minus 60. Now, I don't need to write that like that, do I? That's just going to go to 20A plus minus together is minus. 20A minus 60. What about this? If I've got, let's say, 2 lots of 3A minus 5. 2 lots of 3A is 6A. Then 2 lots of minus 5, minus 10. How about this one? Almost the same, but not quite. Negative 2 lots of 3a plus 5. Here's what I say. I say negative 2 lots of 3a. Negative 2 times 3a. Negative times a positive is a negative. 2 times 3 is 6a. Negative 6a. Haven't finished yet. Negative 2 lots of positive 5. Minus 2 times positive 5. Negative times a positive is a negative. 2 times 5 is 10. Let's try another one. What about if I had negative 2 lots of 3a minus 5? That's negative 2 lots of 3a, which is, well, negative times a positive is negative. 2 times 3 is, that's going to be 6a. Then I'm going to have negative 2 times negative 5. What's a negative times a negative? That's a positive, isn't it? 2 times 5 is 10. Can you try this one? Negative 2 lots of 5a minus 10. That's going to give negative 2 lots of 5a, which is negative 10a. Negative 2 lots of negative 10. Negative 2 lots of negative 10 is going to be positive 20. Negative 10a plus 20. Okay, have a look at these four. Press pause and see if you can do them. Okay, the first one. I've got 2 lots of 5a. That is 10a. And then I've got 2 lots of positive 3, positive 6. 10a plus 6. Next one, I've got 2 lots of 5a. That's 10a. And 2 lots of negative 3. That is negative 6. Next one, I've got negative 2 lots of 5a. That's negative 10a. And negative 2 lots of positive 3. Minus 2 times positive 3 is minus 6. Next one, I've got negative 2 lots of 5a. That's negative 10a. Then I've got negative 2 lots of negative 3. Negative 2, negative times a negative is a positive plus 6. Here are 4 more for you to try. Press pause. Okay, here we've got negative 10 lots of 2x, which is negative 20x, and negative 10 lots of positive 3, which is minus 30. Next one. We've got 10 lots of 2x, 20x, plus 10 lots of negative 3. 10 lots of negative 3 is negative 30. See how those ones there, those two answers, almost the same, but not quite. Next one, we've got 10 lots of 2x is 20x, and 10 lots of positive 3 is positive 30. Final one, negative 10 lots of 2x, negative 20x, changed my colours here, and negative 10 lots of negative 3, negative times negative is positive, positive 30. How did you go with those ones? If you didn't get those right, you should probably rewind a bit and have another go. Okay, this is an example of a complex question. What we need to do is expand out both sets of brackets and then collect like terms. First set of brackets. 5 lots of 2x is going to be 10x. Then I've got 5 lots of positive 3 is positive 15. Now, this is the trap for this next one here. It's negative 2 lots of 3x. Negative 2 lots of 3x. That is negative 6x. And then it's negative 2 lots of negative 4. Negative times negative is a positive, positive 8. And then I just write this rest of it down as it is, okay? Then the next thing that I need to do is identify those like terms. I'm going to circle in green all of my x's, remembering to hold that sign. That's right. And what else do I have? Oh, I have just numbers, so I'll do those ones in blue. Okay, how many x's do I have? Well, I've got 10 of them, minus 6 of them, that'll give me 4 of them. 4 of them minus 2 of them will just give me 2 of them. 2x. And what about my just numbers? I've got 15 plus 8, that's 23, plus another 3 will give me 26. How did you go with that? Okay, how about you have a go at this one? Start by writing down the whole thing, writing down the whole expression. Make sure that you've written it down correctly. Then expand out both sets of brackets and collect like terms. You'll need to press pause here. Okay, I'm going to start my expansion. Negative 10x minus 5 times minus 5. Minus times minus is a positive. And then I've got, oh, plus there, that's nice. 3 times 4 is 12x. 3 times 10 is 30 plus 30. And then just write the rest as it is. Next, I'm going to go through and collect like terms. I'm going to use blue for all of my x terms. Okay, what have I got? For x's, I've got negative 10 of them, plus 12 of them, take away 20 of them. And I can do that in my calculator if I need to. Minus 10 plus 12, that gives me 2. Take away 20 will give me negative 18x. And then what about my numbers? I'll do these ones in green. I've got 25 plus 30, that'll give me 55. Plus 7 will give me 62, I think. And on an exam, I definitely use my calculator to make sure that I didn't make mistakes with that. How did that go? Negative 18x plus 62. Okay, write this one down and then see if you can solve it. See if you can simplify the expression. Don't forget that that there is a negative. Okay, how do we go? I've got 4 lots of 3a is 12a. 4 lots of minus 2 is minus 8. I've got minus 2 times 6a is minus 12a. Then I've got minus 2 times positive 5, negative 10. And then I'm going to write the rest down just as it is. Next, I'm going to identify my like terms. My a terms can be green here. Oh, 12 of them minus 12 of them. There we are. So what have I got? How many a's? I've got 12. Take away 12, that makes 0. Take away 2 of them will give me minus 2, and then plus 5 of them, which would give me 3. Now you could just write all of that in your calculator to get to help you with that. 3a, and what have I got? I've got minus 8, minus 10, that is minus 18, plus 8 gives me back to negative 10. Okay, we've just got one more thing to learn. If 10 lots of 2a plus 5, what do? I go 10 lots of 2a is 20a, 10 lots of 5 is 50. We're now going to learn to go back the other way, to put things into brackets. When we put things into brackets, it's called factorising. So if I've got this, if I've got, let's say, 6a plus 10, I say, well, is there a common factor between this 6 and this 10? I say, well, yes, they're both even numbers. So I say, okay, even numbers are going to have a factor of 2. So it's going to be 2 lots of something plus something. 2 lots of what would give me 6a? 6a divided by 2 is 3a. 2 lots of 3a will give me 6a. 2 lots of what will give me 10? 2 lots of 5 will give me 10. So 6a plus 10, 2 lots of 3a plus 5. What about this one here? 30a plus 50. What I'm looking for is a common factor between 30 and 50. Can you guess what it is? I think it's 10. So it's going to be 10 lots of something plus something. 10 lots of what make 30? 10 lots of 3 make 30. Oh, and that a has to go there as well. 10 times 3a will give me 30a. 10 times what will give me 50? 10 times 5 will give me 50. Can you try this one? I'm looking for a common factor between 10 and 5. What would my common factor be? It would be 5. 5 lots of something. Oh, and I'm just going to write that minus there, something. 5 lots of what gives me 10a? Well, the a is going to go there. 5 lots of what a gives me 10a? 5 lots of 2a, because 5 times 2 is 10. And 5 lots of what will give me 5? 5 lots of 1 will give me 5. So 10a minus 5 is equal to 5 lots of 2a minus 1. And I can check that by expanding the brackets. How about this one? Well, I look at this and I say we've got an even number here and an even number here. So let's try 2. 2 lots of what plus what? Well, the a is going to come here. 2 lots of how many a make 4a? 2 lots of 2a. 2 lots of what make 10? 2 lots of 5 make 10. Can you have a go at factorising these? Factorising just means put them in brackets. Press pause. Okay, so for the first one, I'm looking like something out the front, so many x's plus something or other. Well, looking at these two things here, 5 and 15, what factors do they have in common? Factor of 5. 5 lots of what make 5x? 5 lots of 1x. And 5 lots of what make 15? 5 lots of 3 make 15. Now, if I was writing this, I wouldn't write 1x, I'd just write 5 lots of x plus 3. What about this second one? 8 and 6. What have they got in common? Well, they're both even numbers, so I'm going to put a 2 out the front. It's 2 lots of how many a's minus what there? Well, 2 times 4 is 8. 2 times what is 6? 2 times 3 is 6. So 8a minus 6 is equal to 2 lots of 4a minus 3. Now, I know that this has been a long video, but if you can do all of this stuff, you will be able to pass your exam. Probably go back through it again, maybe work through every question on here. If you do that, you'll be well prepared for our exam next week.